Let's do one more problem with exponential growth. On April 1st, 2020, there were 736 COVID-19 cases recorded in Oregon State. On April 30th, 29 days later, 2,510 cases were recorded. Assuming exponential growth, determine what day in May the number of bacteria cases should have been 4,400. I personally think that this part, what day in May, is just a hint. It doesn't play anything. It doesn't have any bearing in calculating the problem. Okay, so let's go to the next page. So at time 0, which is April 1st, so April 1st, time 0, we had 736 cases recorded. 29 days later, we have 2,510. Okay, so when, and the question is asking, when will we have output of 4,400? Okay. Let's use, first of all, let's use the fact that n equals n initial, or the formula n initial, e to the power of RT. The growth of this bacteria, the growth of COVID-19 is continuous. So n equals n initial e to the power of RT. So using this point, I have 2,510 equals 736 in initial. If you're not, if you're not convinced that in initial is 736, you could use this formula one more time, just and see it for yourself. If you don't know how, look at my previous videos that I posted for you. So 736 e to the power of rate times, and the time was 29 or 29R. So let's take natural log of both sides. So I get natural log of 2510 equals natural log of, well, first of all, before I take natural log, let's divide both sides of this equation by 736 to isolate my E. So I'm going to go ahead and go to the next page. So I'm going to have on the left-hand side, 2,510 divided by 736 equals e to the power of 29R. Now I'm going to take natural log of both sides. Natural log of 2510 over 736 equals natural log of e to the 29R. So using law of logarithm, I will have natural log of 2510 over 736 equals 29R, and now divide both sides by 29. So R equals, according to my calculator, let me write all kind of digits, 042303721. Okay. So going to the next page, now that I know what R is, what rate is, I'm going to write the model that N equals N initial, which is 736, e to the power of 0.0423033721. Okay, and the question is that at well, there's a T here. So the question is that at what time or how long would it take for the population in here to be 4,400? So equals 736 equals 0.04230371 T. And now I'm going to go ahead and divide both sides of this equation by 736. And so then I'm going to take natural log of both sides. So on the left-hand side, I will have natural log of 4,400 over 736 equals natural log of e to the power of 0.04230371 T using the laws of logarithm. I will have natural log of 4,400 over 736 equals 0.04230371 T. Now I'm going to divide both sides of this equation by the coefficient of T. So T equals, natural log of 4,400 over 736 divided by 0.04230371. So that gives me, putting that on the calculator, let's see, natural log of 4,400 divided by 736 divided by, okay, so I'm getting to 2 decimals. Since it's time, I get 42.27. So 42.27. And since the problem is asking us about the day, that's 42 days later. 42 days later. And if you look at the calendar for the year 2020 and add 42 days to April 1st, you end up at excuse me, May 13th. So add 42 days to April 1st, 2020, and we end up at May 13th, 2020. Let me know if you have any questions, and I hope you found this example interesting.